The guys from home, I don't know how they operate. They're not saying anything about sound. Okay, now, guys at home, we put it on record. Whatever that you do on Ciros and you close Ciros, you are unable to save it. You forfeit your design. Therefore, I don't mark that design. It's not part of the test. Are we clear? And every time you'll be required to build it, unfortunately. And ish, load shading. I'll have to check the schedule very close. Our government is killing us. Or should I say, UJ is killing us by not putting proper UPS at QK, because you can't afford that shutdown. Because once you shut down your PC, you shut down your design. However, I will keep it as simple as straightforward to that design because it has so many steps. Yeah, so many steps. And this is the first step. So we're gonna say MPS, maybe today's date, 19. You'll write your name. You can write anything because this is not assessed. Then you're gonna come across this workbench. Okay. Uh, we have this rotate. If you can come here and just do this, you'll see it. Again. Then you come to this side, then you're able to rotate it. Ne? Put it in a certain angle. Then you click on this other one, we are able to do it straightforward. Again. Then you scroll and you click on rotate. Now you're able to rotate it in a close range. Again, on a close range. So these are our MPS work pieces. They come by default. How do you know that you've selected a wrong file when you don't find this? It means you selected model. You don't need model, you want MPS. Next up, you need to go to modeling and model libraries. Ne? And then Festo MPS under. You open it, then you take the, not this, but okay, this one doesn't want to change. What's wrong? Okay, distribution conveyor. I just want a normal conveyor. For the purpose of this, I just want a normal conveyor. Let's see if I can get a normal conveyor. I'm looking for a conveyor that is straightforward. Hey, but there's no conveyor here. I don't have a conveyor. I'll just take the distributing conveyor. We'll use the conveyor that is there. Then you click on add. And you click close. I'm able to rotate. I noticed that the software sometimes it does enable shortcuts after you have tested once or twice, whereby I'm able to use control and shift. See, control. Guys, the maneuvering in a test, you cannot practice it in the test, this maneuvering. It's very intense, time consuming. You need to know, you need to be able to do your 360 before the test, not in the test. You'll regret. Trust me. If you are unable to see a certain diagram, not in the software, it needs to be here in the lab before the test, not during the test. Because during the test, it will bring more dead bodies back. So please make no mistake. Okay. Then there's another shortcut, Y. When I press button Y, it is able to give me a concise angle. Y, the letter Y. Because at times you do need to see these precise angles when you are working around the station. Yeah? Because this you are seeing it from a 2D. It is in perspective a 3D, but you're not seeing it in 3D, you're seeing it in 2D. Therefore, measuring is difficult. And then that's why these guys, when you go to them, né, I think under their better version of software, under here, they have what is called a VR, né, virtual reality. So it is able to, you are able to wear those goggles and you see it like in 3D, whereby you can see all angles basically in a way. Yeah, unlike what we are seeing currently as 2D. So this software, unfortunately, it doesn't have that. Yeah, I think yes. So you see, a VR devices. If we have the overhead mount goggles and the software, it is able to accept that, and then you can work on 3D. Okay, I get interesting, guys. Pay attention, please. If you go to modeling, modeling explorer, you're gonna come across this machine properties, né, under objects. So you're gonna find it like this, and then under objects you look for it. When I click workpiece table, I get then workpieces, and then the machine. Né? On the machine we have its PLC. So it says there's a PLC somewhere here. So inside there, there's a PLC. Yet we are unable to see it where it is physically, but there's a PLC, hypothetically speaking. Okay, and we have a panel also. Where's the panel? We have the panel where we press buttons again. Sharp. Then the PLC, we want properties of the PLC. You want to see what is happening inside the PLC. So you right click on that PLC, then you go properties, and you can just close the other part. It says control here. So under control, it's by default using S7 simulator. Eh? S7 simulator, I believe it's Siemens S7. So by default, it's using that S7. Oh no. S7 PLC sim is a simulator PLC from Siemens. So, but we don't do that. What are we gonna choose? Make a wild guess. Hmm? Are we doing Siemens? No, we're doing Codesys. Codesys, it normally communicates via OPC. So we click OPC client. Okay. Then now all of a sudden we have that section here, OPC client. Okay. Then under items, we have a very nice table, and you click connect. Now this guy comes up. It can see that, hey, something's happening down there. Okay. And then we have codices. We have analog bits and we have the normal bits. And this is where it gets a bit interesting. The bits we are intending to use are these. EB 0.0. Let's come here. You see here 0.0, I 0.0. We are trying to use this one. Although it might not work because of I've approached it differently. I might still need to configure the codices different, slightly different. The approach I'm taking, I'm trying to reduce the steps that we're taking there. If it can work, then we're hitting jackpot. If it doesn't work, then hard luck. We'll have to do the difficult way. So we're gonna take the E, those are your inputs until 7. Ne? The E are your inputs. You drag them to there. You see? So now this changes to EB0 bit 0.0. Okay. Then now we take the A. The A's are actually your outputs. The E's were your inputs, okay? I0, EB0, okay? And now A are your outputs. Then you need to see AB0 there and so on, okay? Then on the panel, as you can see, we have your emergency stop there as I5 according to this, okay? So we will take a different set of bits. They're going to be IB1 bit 0. IB1 bit 0. I pray this approach works. Okay. Then IB1, you look at the difference. IB0 there, IB1 there. So they are not the same thing. They look similar. Right. And after that, click on apply. And then close. On the PLC side now, uh, I want to, the start button, unfortunately, they no longer correspond with, because we have now a panel for, we have inputs on the panel. I'm going to copy here and paste them there. So these are going to be inputs panel. Then they've slightly changed to P1 and P2. Okay, and then we have here I, no, it's still I. Wait, 1, yeah, we changed this one. So we had it as a 0.0, now we have it as 1.1. Okay, now the input changes now here slightly. It's going to be P0. We want to use the panel P0 to run the system here. Okay, then let's see. Symbol configure, build again, and download. Press start. I want to see if this will move. So now press start also this side. We have communication, local host is connected, the client is connected. The software we are using is no longer Fluid Sim, but it's the Ciros. Okay. How do we then put products here? And then this is when the ability to go on the top view is very handy. So now from the top view, if I were to click the blue icon, I click it once, then I click there. You see there's a blue icon coming in there. If I click the red one and I click there, the red one comes in. Okay. Then I change to edit mode. And then I want to click on the workpiece. Then there's my workpiece. I try to place it on the conveyor belt. And then the reason why it's very important for you to see all the angles. Look, I'm going to press Control and take my mouse upward. Oh, you are lucky, guys. It managed to sit. Normally, it just float. So let me add more to demonstrate this again. Okay. Right. Most of the time, when you want to place your workpiece on the conveyor belt, you will discover that the workpiece is on the top. You see that. So you don't add workpieces then when it's full, then you want to place workpieces there. You're going to face challenges. You place only one workpiece, then you move it over. Yeah? I think it's too much information for a day. But let us just uh, get to a point where we are able to get it to communicate. Before we can write any PLC, we will end where we see this moving. Yeah? Maybe we can even latch it so that it moves until the end. Okay. So according to the code that is inside here, I want to see what will happen when I press. The other boring part about this is this one. You need to rotate this. Yeah? You need to rotate this. I might, based on how much I practice before your test, I might incorporate a visualization part whereby instead of us rotating this, we would just zoom to the position we want and we press our start buttons on the separate page. Let's see if the communication indeed is there. Because either way, this is where you need to start. So you see, I'm struggling to see both of them at the same time, which is a bad thing. Then I'm gonna press that button. You see it moving. You see it's moving. So this means that, hey guys, if you can go to my YouTube page and you see the steps I do to configure this. This is what we call IO link device, IO link master, and yeah, so many steps. So at least we've cut all those components because normally PLCs change when we get here. What we have been doing on Fluid Sim changes drastically when we introduce the Ciros part. But now I'm happy to declare hore, we're just going to move with what we've been doing, the way we've configured the Codesys PLC. Nothing will change. We just added the Ciros part, and then because the steps were a lot, guys, and I was not proud to give students so many steps. So now we saw it moving a little bit. Can we just make it to move to stop somewhere? Yeah? I want to make it to move to stop somewhere. Okay. So firstly, guys, when you are on edit mode, yeah, and you try to move stuff, you sometimes they will tend to wanna sink into uh, the bench, but I don't know why it doesn't. As you tend to get used to the app, certain things are no longer possible you know, like you're unable to simulate the wrongs that students do in a way. Okay, so now let me just draw a small, uh, just to make it go and stop for instead. So now the shortcuts that guys I discouraged. Remember, I press here, it just moves slightly. Yeah, but on the on the fluid sim, when you did this, you were able to get it to extend, isn't it? This case, it doesn't run forever. It requires you to give it a latching circuit, for instance. Ane? So that answer of shortcuts, they really need to be informed shortcuts, for instance, especially towards the test. Avoid coming with new stuff without consultation. I don't undermine your ability to think, but I want you to be safe because of once I see Hori, you've done a disaster. I mark it as a disaster. But if you came to me, because my test won't be as difficult, like as opposite, the total inverse of what you have learned. It's not this thing of 1 plus 1 in a class and then solve for exponential what in a test. I'm not that kind of a guy. I'm not setting you for failure. I understand the intensity. It took me over 8 years to learn these things. I cannot just 1 week, 2 weeks, I put you in a deep dive. No, it won't work. And you're not doing my module all alone. This is just a lab component for your test. Imagine you still have that big test, the scary test coming. I cannot be the monster in the building, honestly. So I want to confirm something. My P1 normally is P4, the stop button, but let's see what will be my P1. So now this thing needs to run and stop using P1. Other stuff that we're going to add, we're going to add them next week. Let me just download this and see what will happen. Okay, and start. What I'm trying to prove here is that, okay, yeah, indeed. Huh? P1, P1 is supposed to be, when you press P1, it turns off. When you let go of P1, it turns on. So P1 indeed, it's my normally closed button. You see here, this button here is red. When I press it, that turns off. When I let go, it turns on again. You see that? That's your P1. That's why we're connecting it as a normally open there, so that because of it has electricity in it. Then now, what happens when you press the start button? Start, and this goes stop, and then it stops. Okay, I don't know why it doesn't want to stop, but it managed to stop there. If it was still running, it was gonna fall. So it runs and then stop. Okay, so next week we're going to introduce the the sensors here. Some of them they are normally closed, some of them they're normally open. And if you can pay attention between this sensor here and that sensor there, you see how the other one is its color is much brighter than the other one. So this is how you identify. And even when you come here, this one there. So let me just press. I wanna clear everything and just throw in one component and with edit. So you see this positioning thing is very handy. So when I come there, you see the very same sensor. Look at that. The very same sensor is able to change. And if you look there, that's your I1. It's able to turn on. Then let's go on top of them. So you see your, I think it's I2s or what is it? I2 turns on and off. So when it's not having a workpiece next to it, it's on. When you bring a workpiece next to it, it does what? It turns off. Then this other one, it turns on. Then that other one there at the bottom, it turns on. So you have sensors that are coming with different natural states, normally open, normally closed. Guys, this is for your test two. Ne? I'm gonna come up with different scenarios for this machine, and you need to know all of them. One of the scenarios is your test. It's not easy for me to bring a whole different machine for the test. Yeah, it will be a special test if I tend to do that. I will bring this very same machine but utilize a different scenario because you can program it from a lot of point of views. So you just need to master the scenarios, then that's your test, one of them. Are we clear? Thank you guys. Let's meet Friday and next week as well. Sharp.